Welcome to the Borei-class submarine subbrief. The Borei is the replacement for the famous Typhoon submarine Russia used during the Cold War and after the Cold War. This is the ballistic submarine they built to replace it and the one that they're using today. Now, the Borei comes in two different configurations, simply called Borei-1 and Borei-2, and there are significant differences in the equipment between those two submarines, but just know that it's all the Borei class. They're building 10 of these. 7 have been commissioned. 3 of those are the Borei-1, and the remaining 4 are Borei-2. The 3 that are under construction will be Borei-2 as well, for a total of 10. Now, the one thing that the Borei class has in common is that it's a ballistic missile submarine. So it has 16 ballistic missile tubes behind the sail, vertically launched, and it shoots 53 centimeter torpedoes out the bow. A lot of the equipment in between the bow and the missile compartment is different. And so we'll talk about those differences today. Let's begin with the missile compartment right behind the sail there. You can see it's a 16-cell RSM-56 Bulava SLBM launcher. Shoots intercontinental ballistic missiles with multiple warheads in each one. And on the bow, you have 53 centimeter torpedo tubes. Now, one thing I'll begin pointing out here is the Borei-1 only has 6 torpedo tubes on the bow. The Borei-2, the current one, the most modern one, has 8. They've added an extra tube port and starboard side. All right, sensors and countermeasures. Let's talk about the countermeasures on the bow. This is often confused with torpedo tubes. These brow launchers are not torpedo tubes. These are special purpose tubes. They're external countermeasure launcher tubes. They're not reloadable from inside the submarine. They do not go into the torpedo room or the pressure hull at all. They're completely external to the submarine, but inside the outer shell. And what I mean by outer shell is that this is a double-hulled submarine. What we're looking at is a steel shell over a steel pressure hull that's inside of it. And inside the pressure hull is designed to withstand the pressures of depth, and that's where the people and most of the equipment are. And out on this outside of that is the shell that we're looking at here painted black. External tubes like what we're looking at on the bow, the brow launchers, are in the space between the outer hull and the pressure hull. The black boxes that you see going down along the side of the submarine, those are vents, free flood vents that allow seawater to get in between those two hulls. You'll notice as you go along the missile compartment, instead of having a small rectangle vent to allow seawater in, it is a long opening that runs the length of the missile compartment. That is to ensure even flooding of the area between the two hulls, the outer hull and the pressure hull. So there's no air pockets in there. You don't want any air pockets because that one can make a little bit of noise, and air compresses is the second problem. And so you don't want anything that's going to be compressed by pressure that shouldn't be. So you want the free flood area evenly flooded, fully flooded with seawater between the pressure hull and the outer hull. If we look at the sail, and we're going to go over this in detail, but you can see that they have one of the periscopes raised. That's the PZ-KE series of periscopes in front of the bridge. The bridge is where you see the 4 or 5 sailors standing there. And then behind them, you see the large radar ESM mast, that huge tree trunk of a steel mast that's raised up hydraulically. And on top of that is the Snoop half radar. And right below that, the beige color is ESM, a surveillance system. Take a note real quick and look how big that sail is compared to the people standing in it. This is a large submarine. We've broken down the 2 different types of sail configurations from the Borei-1 to Borei-2, and credit to Mr. Richard Stern on Twitter for supplying this for us. He drew this. In the Borei-1, you have what's called the commander scope and the navigation scope. It's always standard to have 2 scopes. The big thing is those go through the pressure hull, which is a bit of a problem. So in the Borei-2, they made them non-penetrating masts. So they're basically a camera on a pole that is still raised and lowered, but doesn't go into the pressure hull. Behind that, we have the whip antennas, the ESMs, of course, the HF and VHF communication antennas are all lowered in the picture. You don't see them. but just they're behind where that large ESM mast is. And then they have the snorkel mast. And behind that is the satellite navigation mast, which often is cone-shaped. We have a good picture of that coming up. I do want to mention the snorkel mast real quick. The snorkel mast, when it's raised, is sucking fresh air into the submarine that can either regenerate the atmosphere inside the submarine for the people to breathe, and it can also supply fresh air to the diesel engine when that's running. So I've often seen people mistakenly say the snorkel mast is for exhaust. It is not exhaust. It's actually an intake. The exhaust comes out in different areas on different submarines. On this one, it comes out the sail right below where the mast or snorkel mast is. All right, here's the mast arrangement in a 3D drawing. Credit to Mr. Stern again. I want you to take note of the green cone-shaped antenna. That's the satellite communication antenna that I was talking about. All right, here's the Borei-A picture. This is in, looks like St. Petersburg Navy Day Parade. They participate in this every year, and it's often a good opportunity for OS&IT people like myself to get pictures of this. Very high definition and detailed. Nothing new in this picture, just a different angle of what we've already talked about. Here's the Borei-A. Couple differences to the outer hull. You can see that the free flood area comes forward to the sail about halfway. So it is much more than just the missile compartment there, allowing the water to get in and fill that void between the two hulls faster. That would help facilitate a faster dive time, among many other things. Great picture of this submarine at sea. The yellow antenna that you see behind the sail, that's part of a tugboat that's alongside of it. But if you look just forward of the sail, you can see that the capstan is raised, and that's where they would use the capstan to for line handling, to if they wanted to pull the submarine closer to the pier. Instead of doing it by hand, because this thing is massive, you would use a rotating capstan to pull the line for you. All right, so we talked about the 10 submarines that they are building. 7 are complete. They've been commissioned between 2012 and 2023. There are 3 more in construction right now in the assembly building, and we fully expect them to be done in the next couple of years. These are built in Sevmast Shipyard, that's in Russia, right there in the White Sea. That's right south of the Kola Peninsula. It's a very secure port, a very active shipyard with a very long history. They've been building submarines here for a very long time, and they've gotten pretty good at it too. They pump them out pretty fast. And they do more than just nuclear here. They can do the kilos, they can do the conventional submarines. The Lada class is built here. If it's a submarine, it's probably a version of it has been built in the Sevmast Shipyard, and probably the first one. They build a lot of Hull 1s here before they build them in other shipyards. Here's the Borei-class by the numbers. It is a nuclear-powered submarine. The OK-650 Bravo pressurized water reactor makes 190 megawatts, has an OK-9 turbine, and the propulsion that moves the submarine through the water is not a screw, it is a pump jet. It is 170 meters long and displaces just under 15,000 tons surfaced and just under 20,000 tons submerged. That's with a full Bulava payload. Top speed is 25 knots submerged, 15 knots surfaced. It has a 16-cell Bulava submarine launched ballistic missile compartment. It has 8 torpedo tubes for Borei-A. Borei-A, the first 3 hulls, only had 6 torpedo tubes, but they both fire the Test 71 and 53 series of torpedoes. The 53 series is a number of anti-submarine torpedoes of different variants that we're not going to go into each one of those. Just know the 53 stands for the diameter of the torpedoes, 53 centimeters. Makes it easy to remember. It does have 6 special purpose tubes, eyebrow or brow tubes on the bow above the torpedo tubes. We'll point those out when we see them again. For the sensors, they have a pretty good sonar system called the MGK 600 Bravo. Bravo is the modernized version of this, both an active and passive sonar system. And it's pretty good. I have to give it to them. They've everything that I've seen with their displays and the capability of the sonar system is very modern. So they've really caught up in that area since the Cold War. They have the MIRV-59 surface search radar in the Borei-A, and they have that combo R43M radar ESM in the Borei-A. The Borei-A has the commander's periscope, like I talked about, with the navigation scope. For the Borei-A, they use non-penetrating mast called Paris 98KP and Paris 98UP optotronics mast. Now, you might be asking yourself, what is the difference between an attack periscope and an optotronics mast or a navigation mast? And it's really the size of the head that is exposed out of the water. Whenever you're using a navigation mast, you usually have a wider field of view through the scope or on the TV screen in the case of a optotronic mast. And you're not too worried about being stealthy with that. You just want to safely navigate or safely not run into something. You want to see more clearly around you in a wider field of view with the with the navigation scope or the Paris 98UP. The attack periscope usually has a lot more stealth built into it, including a smaller head that is exposed above the waterline, and it talks directly to the fire control system. You know, you can ping a bearing with a push of a button and send that bearing to the torpedo room, and that pushes it to the whatever weapon is selected. And at least that weapon knows what direction to go. If it doesn't have any other information, at least has a start if it is used. It gets a lot more involved than that, but that just gives you an idea of why they have two. Plus, it's always a good idea to have two systems for everything on a submarine, because if one goes down, you want to have a backup, especially in critical systems that allow you to see outside the submarine, like an optotronics mast does. And the towed array is the shark tail sonar that they've had for years. Shark tail goes all the way back to the 80s, but they've improved it over time. It's all part of the MGK 600 system. All right, here's that nuclear reactor. I love this photo. It's OKBM, African TOV development. Basically, it's built by Russia for Russian submarines. It feeds, 50,000 horsepower steam turbine that turns a single pump jet that pushes the submarine through the water. It is a water-cooled thermal neutron nuclear reactor, produces 190 megawatts of power, so very powerful, and uses 20 to 45% enriched uranium-235. And it's a derivative of what was used on other submarines like the Typhoon and Oscar and Yasin class. And if I'm not mistaken, this photo is actually of it looks a lot like the Yankee, but it could be modified. So yeah, as you can see, they don't change a lot in the design. They just make these more powerful. And this is the most modern one that they have here. All right, let's talk about sonar. The MGK 600 Bravo, Irdish, we called this shark teeth in the U.S. Navy. That was the American name for it, our code name, if you will. It's an integrated sonar system that does it all. It has a low-frequency active-passive bow array. It has a flank array, and on the Borei-A, that flank array can actually go active as well, which is pretty incredible. And then, of course, the towed array, the shark tail we talked about. It has the whole kit right there. It is connected with the combat system, so whenever they track a target, the combat fire control system is automatically generating fire control solutions, which just means it tells the torpedo or the missile, they can shoot missiles out of the torpedo tubes as well, where to go to hit the target, right? And it's a bit of a science to get that solution just by listening to a target and watching it for a period of time, and then you use simple geometry to figure out where it is now, how fast it's going, how far away it is, and then where it's going to be by the time your weapon gets there. You have to know how fast your weapon is and a lot of other details that they would already know. Well, the fire control system does all that for them. So all they have to do is assign the tracker, wait a few seconds, and then they're ready to shoot. See, the active sonars are located on the front and flank arrays. The flank arrays on the side are for the Borei-A, and they can go active, which is, like I said, that's a very new capability. Usually the original flank arrays were all passive. The point is the flank arrays are very good, much better than the bow array. And it gives them a near 360, we'll just call it 360, view all the way around the submarine. No more sneaking up on submarines from behind with flank arrays. That's going to be very difficult to do now. It says here, this is from Jane's, that they have an estimated range of almost 130 kilometers. That is just the range modes that it has. Obviously, sonar range is 100% dependent on the environment, and then, of course, the equipment as well. Here's that Radian U radar ESM combination. NATO name is Snoop Half. So it's always fun when you get a Snoop Half detection, because you're watching the Russians do their thing. It's a derivative of what used to be Snoop Tray, which was the older version of this. But Snoop Half is a combination of radar and ESM all in one module now. ESM is a passive system, just listening, picking up radio detections. The passive detection is about 173 nautical miles. But again, just like sonar, that depends entirely on the power of the radar that's being transmitted and the conditions topside. But just think that 173 nautical miles would be the maximum in ideal conditions. Active detection can be as much as 108 nautical miles away. That's certainly capable. The power of the active on the sonar system can certainly reach that range, absolutely. But again, it would have to be deep water Pacific Ocean or deep water Atlantic. You're not doing that in shallow water. All right. So here's the R43M, a radar ESM complex. This is on the Borei-A. This is the upgraded ESM, and it's got that white shroud over top of it. It's a lot more sensitive. It operates in the I band, which is the 8 to 10 gigahertz band. This IOC'd in 2014 and is very good. We don't know a lot about it because it's only been out for, 8-10 years now, but we just know what band it operates in. It is a two-dimensional surveillance navigation radar combo. The radar part of that is it just gives you bearing and direction. It doesn't give you altitude. So that's what a 2D radar means. All right, here are the PZKE-21 and Type 01 periscopes. This is on the Borei one. These are the older periscopes. These penetrate through the pressure hull into the people tank. That's a liability, and that's why they wanted to get rid of these. They only put these periscopes that were also used on the Typhoon, same periscopes, on the first three hulls, because that's Borei 1. And then Borei 2, they don't penetrate the pressure hull at all. And here they are. This is the Paris 98 periscopes, the UP and the KP variants. These are unified non-penetrating scopes. They're connected to the fire control system. You have basically a big one and a small one. One's more stealthy than the other one, but the smaller one doesn't have as big a field of view or as many good a picture as the larger one has. Let's see, the visual optotronic channel has low light television. That's the attack mode. TV thermal imaging and laser rangefinder would be on the Paris 98. Magnification is up to 12 times. That's really good. Having a 12-time magnification is something that's we didn't have that in the Cold War. It wasn't quite that much. Anyway, but two very good periscopes. We got to give it to them. They've come a long way. They're still much larger than anything the United States uses, but as long as it fits and it works, it has the capability, a good capability. Let's just leave it at that. All right, let's talk about torpedoes. Test 71 heavyweight torpedo. This thing is a nightmare. It is a anti-submarine torpedo, wire guided, has the Sapphire guidance system, which means it's very hard to decoy away. It goes into a countermeasure homing. Whenever it reaches a countermeasure, it will blow through that countermeasure, do a search again, and if you're anywhere in the vicinity, it's going to see you. So this thing, it's scary, and it's heavyweight, which means it can go not just blow up your submarine. This thing will blow your ship out of the water and crack the keel. So it's not a submarine-only torpedo, but it can do both. It's dual purpose. It has a 200 kilogram high explosive warhead. Speed is up to 40 knots. Range of 23 kilometers max range. Depth is in excess of 400 meters. And nasty, nasty weapon. Type 53 torpedoes. There are a lot of these. Many, many different variants. The important thing is they're all the same diameter. They fit in the torpedo tube. And so they shoot the Type 53 family of torpedoes. These are anti-ship, anti-submarine. long running series, high speed, 55 knots, range of 24 kilometers. There's just so many different of these to talk about. Just know they keep upgrading these. So I'll tell you a quick story about these torpedoes. I saw a lot of these launched in the Barents Sea during their war games. They come out every summer, usually around May or June, and they do a week's worth of war games. And they shoot these weapons, obviously with no warheads, just shoot them for practice at each other. And I never saw a submarine seriously try to avoid one of these. So for whatever reason, whenever they shot one of these during a war game, the target submarine that was designed to play the rabbit and be hit did not try to get away. And of course it was hit. So I can't tell you how good it is. And that was many years ago. So hopefully they've made improvements, but honestly, the only way that this thing was hit when I was watching it was because the target submarine did not try to get away. So take that for what you will. This weapon, I see it all the way back in the 1960s, but don't judge that torpedo today by that number because they've modified it every couple years since then. So it's not the same weapon as a 1960s torpedo. Also, take a look at the picture in the bottom right. I've pointed out the brow launchers. Those are the torpedo countermeasure launchers that are above the torpedo tubes. And this is the best picture I had of those. So whenever you see this submarine again, and if you look at submarines like the Akula, has the same brow launchers, has the same decoys. Yeah. So that's what those are. All right. Here's the RSM-56 Bulava ICBM, submarine launched intercontinental ballistic missile designed to destroy cities. This thing has multiple reentry warheads, can have up to 10. If it has 10 MIRVs, then it's very small warheads, or it can have 3 city killers. You know, it's bad news no matter what, if this thing is ever launched. The missile can carry decoys. Yeah, this is something that they began doing in the 90s. And I don't know anything about our own missiles, but this is pretty scary. These reentry vehicles do not re-enter in a straight line. They spiral in like a corkscrew. And on top of that, they splinter decoys every few seconds. So one warhead will look like 20 by the time it gets into the reentry position. It uses internal navigation as well as GLaSSNOS. GLaSSNOS is just the Russian version of GPS. Because obviously in a conflict, the United States would turn off GPS, or we would encrypt it is what would happen. We'd still be able to use it. You just need to have the encryption key to use it. Yeah, which means all of your cars and your navigation system would stop working. And so, but the more important thing, the Russians and the Chinese would not be able to use it either. So they made their own. GLaSSNOS is Russian GPS. Inertial navigation is very cool. And I used to not be able to talk about this, but I'll tell you how it works now because it's been a while. It takes a fix of a specific star. I think one of the common ones is Polaris. It's going to be a star that doesn't move in the sky. And by its position after launch, it knows exactly where it is over the Earth, not by looking down, but by looking up at where specific stars and constellations are. And then it triangulates, or has more than just 3, multiple directions, crosses its orbital position, and it's very accurate. It's shockingly accurate. Astronavigation is. And yeah, the Russians do it too now, and they're good at it. All right, it does have 3 rocket stages, solid fuel and liquid fuel combination, which is bonkers to me, but hey, that's just the way Russians play. Solid fuel is very dangerous, man. But that's how they do it. They have solid and liquid fuel. Max range is 4,500 nautical miles. You can hit just about anywhere in the world that it needs to. Obviously, the targets that it's going to be looking for is anything in the northern hemisphere. Can be targeted. I should mention that these submarines are deployed both out of in the Northern Fleet, so above the Kola Peninsula, and in the Pacific Fleet. So anything in the Northern Hemisphere can be reached easily. If they want to hit the Southern Hemisphere, they can hit most of that too, but they have to go down south a little bit. So CEP, I should mention what CEP means. That's basically the error of impact. So that's the estimated amount of error. It's only 250 meters. So when we're talking about nuclear weapons missing by 250 meters, it kind of doesn't matter, right? Because it's close enough to hit. All right, final thoughts. Borei-class submarines, like I said, successor Typhoon class. It's a very successful design. It is quiet. I don't want to go into how quiet it is. Just know that it is quiet. They've built a good submarine. This thing is reliable. It goes to sea regularly and is not publicized because, like the United States, we don't publicize every time we deploy a submarine. We don't talk about it at all, actually. Well, neither do the Russians. Just know that these things are consistently coming in and out of port every couple of weeks. They have 7 of them. And, there's always some in port in maintenance, and there's always some being deployed. And they're reliably performing their strategic deterrent mission. Oh, here's an important point about the hypersonic missiles, the Zircon, and there's another one called Avangard. Yeah, the Avangard glider. It can't launch those. It's just the tubes and the fire control system and all that don't communicate with those weapons. And in order to fit a Zircon missile into one of these ballistic missile tubes, it would need to have some sort of sabot sleeve, so it didn't just rattle around in there. Just like whenever the Americans put Tomahawk missiles on our SSGNs that used to be Ohio-class SSBNs, right? We were able to fit like 7 Tomahawks in one of these tubes because they're so big. But you couldn't just throw 7 in there. You need to have a sleeve around them, and then the electronics to communicate with it and all that stuff, and then the insulation to protect it from the temperature changes, of course, and everything else that goes along with that. Well, they didn't do any of that for the Borei class, so they do not launch the Zircon missile or any of their hypersonic weapons out of this submarine. It's strictly nuclear strategic deterrence and nothing else. Now, having said that, there's nothing stopping the Russian Navy from doing what the Americans have done and take 1, 2, or in our case 4 ballistic missile submarines and convert it to shoot cruise missiles. They absolutely can do that. They just haven't. And they really don't need to, because they can shoot their hypersonic missiles from other platforms. And they've demonstrated that. The Zircon missile does work. They just don't have a lot of them, And we've seen Zircon missile launch fails as well. So we're not sure how reliable it is because we don't have a lot of data yet. They have a handful of launches. Some have worked, some did not. And we know that they just don't have a lot. Anyway, the point is, Borei class 1 and 2, backbone of the Russian submarine fleet, reliable submarine, does its job quietly, and is strictly a ballistic nuclear missile platform that has torpedo tube capability. And it can shoot cruise missiles, not the Zircon, but cruise missiles out of the torpedo tubes. All right. Well, thanks for the support on Patreon, everybody. I really appreciate it. And we'll see you in the next lecture. Have a great one.